Okay, hello everyone. So today I'll be teaching you how to do conditionals and arrays in Java and Kotlin. Okay, so the class is going to be very interesting. Um, I know you guys haven't done any much interesting stuff in your other classes, and you guys have don't have much classes. So, I'm going to be teaching you guys about conditionals and arrays. Hope you guys like my class. I spent a lot of time making it. This is currently my nth video. I say nth because I don't remember how many videos I've done, and somehow I seem to mess it up. And there's always an issue somewhere somehow. I have to redo it. So this is my nth video, and it takes effort to make these videos or even the live stream. Um, but because I will not be free during the time I'm supposed to teach, I'm making this video so that that time you guys can watch this video and get past and understand the classes. So what will I be teaching in this class, or what will you be learning? I'll teach you about conditionals, talk about operator basics, if statements and expressions, switch statements, and when statements. Okay. Then we have arrays and collections. I'll teach you the basic intro into arrays. I'll give you a basic intro into and list set and maps. So that will be it for our class. And any other thing you want to know or you will be taught will be in the next class. But this is what I'm going to cover. I hope you guys find it interesting, and it's actually a very interesting topic actually, especially arrays and collections. We use it everywhere in Java and Kotlin. Also, if statements and switch statements, they are the basic for how to understand how to use control flows, which I will also be teaching you later. Okay, so let's get straight to the point. I have a repo here. This one is for Kotlin. Uh, sorry, this is for Java. So you may notice I have some stopped methods that I put in comments. I commented them out. I didn't want to have to type everything and waste everybody's time. So I commented most of the stuff I'm going to be using to teach you guys. Okay, so let me just not show you guys the actual code before we start. So the method is very long. Okay, so this is my Kotlin repo. If you guys want the repo later, I can share the repo with you guys. The links to the repo, you can just copy it and maybe play with the code. But I'm just informing you that I have a Kotlin repo, and this is my Java repo. They'll both run the Kotlin and Java code that we'll be using in this tutorial. Okay, so let's talk about operators, the basics of operators. Operators are special symbols that perform specific operations on one, two, or three operands and then return a result. So what does this mean? Okay, so let's say we have an operation like um, 4 plus 5 is equal to 9. Okay, what is the operator? The operator there is plus, okay, and the operand there, you may have noticed this operand here, and you may have been wondering what does an operand mean. An operand is like the target of an operator. So 4 plus 5 there, 4 and 5 are the operands, okay, and the result there is 9. So 4 plus 5 is equal to 9 is an operation as a whole is called an operation. Okay, so there are additive operators, plus, minus. You have used this so many times when you are counting your money. Excess times. There are multiplicative ones, multiplication table that you have learned most of the other things you have done. So star multiply. This one is for multiplication. This one is for division. This one is for division also, but it returns the remainder. Is an equality operator. Okay, equal to, not equal to, and it's this and is used to join operators or is used to join operators. Okay, so you use it to join two or more operations together, not operators. It's used to join two or more operations together and return a single value. Okay. So it will take the value of one operation, then join it to the value of another operation, then return a value based on how it works. You might have done logic before, true, true, equal to true, true, false equal to false. That's the same way logical and works. So here true, true is equal to true, true, false is equal to true also. Then false, false is really one that returns false. So that's basic stuff there for operators. I'm not going to go too deep into this because your next class someone will go deep into operators here. So I'm not going to waste time here. The next class is going to cover all that. I'm sure the teacher will do well. So I'm just going to try to introduce the parts of the operators that I touch in the code. Okay, so for the next part, we're going to talk about if statements and expressions. Okay, the if statement is the most basic of all control flow statements. It tells the program to execute a second section of code only if a particular test evaluates to true. What does this mean? Yeah, you're seeing this code and you're seeing what's happening here. If true, do something. This is just an stop statement that I wrote out. Okay, it's not going to actually run in Java or Kotlin. It's not actually compiled correct, syntactically correct. Also, there's no do something variable and defined anywhere, so there's nothing to actually do, and uh, nothing can actually work here. So what I'm just trying to show you is that an if statement, whatever is in this if statement brackets here, should resolve to true. Okay, so that's how if statement works. Let me go to my repo here, and for my first example I'm going to stop this method here. Okay, so let's imagine we're playing a game, and it's a game of cards. There's this game that is popular among Nigerians, and many Nigerians play it. It's basically a game called What. Okay, so if you don't know about the game, I'm going to teach you how the game works. um there's a last game on deck, or there's a last card on deck, and you basically have to find something that matches that card. Okay, so maybe if the last card on deck is a 3, you have to match it. Is a 3 of cross. The last card on deck is a 3 of cross. You have to match it with either a cross of something else, but it has to be a cross, or a 3 of something else, or maybe a 3 of star or something like that. Okay, so you have two ways of matching the last card on deck. Okay, so here I've created a an example that shows you how to do this. Okay, so how to use if statements. Okay, so my example actually covers more than I actually should cover, but I can still use it to show you guys how it works. Later we'll cover that part. Don't be distracted by this part. Okay, so the if statement here. Okay, so we have last card on deck here. Let's say okay, let me comment this out because it will actually give me issues when I'm working on that part of when I'm running the code. Okay, so we have this part here. Let's say and let's imagine that the last card on our deck, or the last card someone played in the words game that we're playing, is 2 of something. We don't care what that thing is right now, but we want to match it and play our own game. So what we're actually doing here is creating a an application that can play words for us. Okay. So that application will be able to intercept and get what the last card on deck is and play it for us. So we are both creating an application that can beat anybody in the game of words. Okay, so this last card on deck now is this if statement here. We will now check what the last card on deck is, and then try to play something based on that. So for our example here, um, we are assuming that we have 3 of stars actually. It doesn't actually matter what the stars say, what you are trying to match it based on is 3. So you see this statement and you assume something is going through your mind and you're like, what's going on here? What's happening? Let me explain it to you. Anytime this last card of deck is called and when the code is running, this last card on deck is replaced with 2. Okay. So basically the code is like this. 2 is 2 equal to 3. This is a 4, this is false, and this code will never run. Okay, let me show you how. Let me show you that this will never run. So let me compile my code, and after I've compiled my code, okay, um it should not print anything. It should just go okay, say fail to connect. Why are you failing to connect? Okay, so um fail to connect. I don't know why. Okay, so yeah, so my code is run has run now and nothing shows up. So basically, what I'm trying to teach you here, what I'm trying to show you here, is that how if statement works. Okay, is the most basic of flow statements. Okay, it executes a code when this part here is true. So let's go back here and sorry, that was the Kotlin repo. This is the Java repo. Let's go back here and redo this thing now. Let's say this is three. Okay. So when this three here is called, when this last card on deck here is replaced, to be replaced to three, and it's now check if is three equal to three. If three is equal to three, it will print this. Okay. So let me run this again. You should print play three of play three of stars. That's what you should print in your uh, output right here. I don't know. So yeah, so you should say play three of stars. I don't. There was an error that was showing up, but it's gone. I think it was a mistake or problem with the site. Um, so that's it for if statements in Java. Okay, I commented that part out. That's it for if statements in Java. Okay, so let me go to the Kotlin parts of the code. Also, I also made this mistake of bringing everything there at once, but it's okay. I can work with it. Um, uh, so if statements in Kotlin, they are basically the same thing, just like you declared your field here. These things are called field in Java. In Kotlin, they are called variables, properties. They're actually called properties in Java, but in uh, they are actually called properties in Kotlin. Sorry, but in Java they are called fields. Okay, so in Kotlin, my property um last card on deck is equal to two. Still the same thing with Java, just some minor changes. There are no semicolons, and I call print directly, so you can just notice that it's almost the same thing. So if you run this, the same thing should happen. Okay, sorry, I should comment this part out. Mm, Let me stop this and run it again. Okay, that's not stopping very easily. I noticed that the Kotlin compiler for this was very slow. The Kotlin compiler for REPL, it's usually slower than the Java compiler for some reason. It's just super slow. Like I don't even understand. Like so many things are wrong with how slow it is. Like it's very tiresome. Okay. I'm resisting the urge to not to go to the next place. Okay, so you can see the code has run now and nothing shows up because 2 is not equal to 3. So that's basically the definition for if statements. Okay, so that's just it. If statements in Java and Kotlin, they are basically almost the same thing, just for a few syntax changes. So let's talk about if else statements. Okay, so let me uncomment this part of my code that actually commented out. Okay, so okay, so let's say our last card on deck now. We're still playing that what? Our last card on deck is now three. It's now two. It's still two. Okay, but we have three, and that's our only card or the only card we have. Okay, so we can either play that only card or go to the market. How do we represent that? Maybe we can say if last card on deck is equal to two, is equal to three. Do this. Then again, we'll come again and say if last card on deck is equal to this, is not equal to three, then do this. But that's just very verbose and others. But you know that okay, if it's not three, or if last card on deck is not equal to three, um, just do something, whether it's 100 or 200. Nobody cares what the last card on deck is. I don't have that last card on deck. Three is my final card. Okay, so let's run this code. You see how else statement works. Else statement is just it creates an a secondary part of execution for your if statement. So when you run this code, you will see that what prints out is market. Okay, because you have tried to evaluate your last card, the only card you have. Okay, and it's three. Okay, since you don't have that card to match the last card on deck, you have to go to the market. So it doesn't matter what you have. Okay, so what it prints out here is market. Okay, so that's what happens when you use the else statement. Okay, the if else statement. Sorry, not the else statement. Um. Okay, so let me teach you guys about expressions in Kotlin. Expressions are not available in Java actually. I don't know. Okay, I know why. I can't say I won't say I don't know why. Kotlin came right after Java. Java had some issues with verboseness and all that. So Kotlin came to um, make things better. Okay, so that's basically what Kotlin does. So I'll comment this part of the code out and show you guys how if expressions work. I've basically um, written most of the code. Just don't want to stress on writing it out. So let's say we are still doing this. I have to comment this part out because I still use last card on deck. Okay. Okay. So I have my last card on deck. Everybody can see my last card on deck is two. Okay. But instead of me simply just printing out like I do here, I just print out some things and all that. Instead of me just simply printing that, I want to assign whatever my result is to a variable in Kotlin. Okay, so this if expression. Okay, so if you don't know the part I am in now, I am in this part here, the if expression part. I'm trying to explain that part. We have done the if and the else statement. I'm going to actually touch on the if else statement, but I'm trying to explain the if expression right now. So the if expression I have told you is only available in Kotlin because Kotlin is more new than Java and it has better features. Okay, so I am trying to do the this is the basic check or the basic equality operator that I used to check the value and then it evaluates to true or false. Okay, but in the end, I'm trying to assign a value to this variable. Okay, so you should see that this variable here, since the variable is not equal to 3, you should still play say market. Okay. Um Kotlin takes a lot of time to run. Okay, so we have to be patient and have to wait for it to know the value of the if expression. Okay. So this is what we call an if expression. They call it an if expression because the if statement is on the right hand side of the equality sign. Okay, and it's not on its own like just this one here. You can see how this one is. Okay, so our code has run now and it returns market, which shows that it's correct and everything works out as it's supposed to work out. Okay, so that's it for if expressions. Let me also comment this part out. Then I'm going to talk about the if else statement here. I'm going to use Java code to talk about the if else statement. Okay, so here, let me comment this part out. I commented this part early, the code. Okay, let me bring it up. Okay, so let's say now we don't have only one card that we want to play. Okay, we have two cards. Okay, so what happens? You either say if my last card on deck is equal to 3, then later you come again and say if my last card on deck is equal to 1, or whatever, or whatever, or whatever, and you start putting if statements up and down and up and down and up and down, and then it's running and running and running. Or you can just put if this is equal to this, else if this is equal to this, and then if I don't have both of them, do this. So let's imagine a scenario where you may want to use this exact kind of else if and if statement and just one else, this else. Okay. Let's say the scenario that you have your the card on deck or the card on top of the deck. We're playing the what game now is two. Okay. Then the two cards in your hand, you have two cards in your hand right now. You don't have one card. You have two cards. One is two, and the other is three. Okay, so you have three of stars and two of cross. Okay, as your games. You want to check if the game there on the deck is either two or three. So here I'm checking if the game here is three, and here I'm checking if the game is two. I don't want to write one if statement and check if the game is three. Then later write another if statement to check if the game on the deck is true. I want to do both of them together. And if both of them I don't have them, I go to the market. So you can understand. So you can use if else if to do this. Else if also creates another branch and checks your code. Okay, so since my code is two here, okay, let me check. Okay, nothing is conflicting and everything is green. Let me run this. My game should say play two of cross because it will check here and this is false. Okay, yeah, play two of cross. It should now check this and run. Then if you don't have it, like let me say, if you don't have it, like you have five here that someone played and it's now your turn to play, you have to go to the market because you don't have uh, whatever is needed. Okay, so you can see that market. That's it for if statements and if expressions. I'm going to comment that part out and go back to my presentation. Okay, so I hope that expression was if expression was very helpful. I hope you understood that. I don't know. For this my example, I use this val message. If battery is equal to 100, um set the message to battery full, else set the message to charge. So imagine a scenario where your phone is charging. If your phone is equal to 100% battery, it should say battery full. And if it's not up to that, it should say charging. So this is a good example for where you want to um, write if else statements. If else if expressions, not if statements. If statements are different, these are statements, okay, but these are expressions. They return a value. Okay, so let's go to the next part of the slide. Okay, so I'm going to teach you guys about switch and when statements. Okay. Switch and when statements have a number of possible execution paths. Okay, they work with primitive and more types of if statements. So you might notice before I did some things I showed you. I did this on purpose. I put false here on purpose and I put true here on purpose because if statements they actually work with boolean types. Okay, boolean types are types that are either true, false, 0 or 1 or whatever. Okay, not or whatever. Sorry, they are just true or false, 0 or 1. 0 is false, 1 is true in computers. If you don't know, you know now. 0 is false, 1 is true. That's how computers work. Okay, so true or false is what if statements work with, but in switch statements, we work with it works with more types than if statements. So you can't just work with Boolean types or true or false statements. You can work with so many other types, strings, integers, and other ones. Switch statements are only are available in Java, and while when statements are available in Kotlin. Okay, so if you don't know, you know now. You can actually not use switch in uh, Kotlin, and you can't use when in Java. Okay, switch statements are only available in Java. When statements are only available in Kotlin. Kotlin made a replacement for switch statements, and you have to see why they did that. And it's actually a cool reason or something like that. Okay, so this is an example of switch statements in Java, actually. So I'm creating a card here. Okay, the card is three. Okay, so let's say we're still playing that game of what? Okay, when someone deals you a card, okay, or when someone your opponent plays a card, you're actually supposed to react to a way the person plays the card. I'm explaining this for people that don't know what. Okay, when your opponent gives you a card that has the value of one, you are supposed to suspend yourself and you will not play. What people call that is hold on. Okay, but when your opponent plays you a card of something that is called two, you're supposed to actually pick two or take two extra cards from the market deck. Okay, or when your opponent gives you a card that is what that is has the value 14, you're supposed to go to the general market. That's how what works. Okay. So I'm trying to like use a switch statement here to kind of break that down instead of writing all those if statements that we used to write and write all those things in a very long manner. So this is the way it's I wrote it. This is my example in uh, Java. Okay, so let me go to the repo. Um, I have this. I have written it out so that I don't waste time writing it again. So this is it here. I have int here, the data type of integer, and the value here is card is three. Sorry. So it's I write a switch statement. Okay, and then pass the card here. I have this string here that I want to display. Okay, this string is what my is what should display when someone has dealt me this card. Okay, so if the card is one, my display should say hold on. If the card is two, okay, this case here, case two, my display should say pick two. If the card is 14, my display should say general market. Okay, but if I don't have any of these other cards, my display should say continue. Okay, so you will notice this break here, break here, break here, break here. Switch statements actually has this issue where if you don't break this, it will run this, run this, run this, and run this. If you don't break it, so this break here is actually to like say, run this and stop. Run this one. If it's one, do hold on and stop. If not, you have errors like your switch statement will actually fall through. It will set it as hold on, then set it as speak to, then set it as general market, then set it as continue. Then you now come to code, you now be seeing errors and it's writing continue and you're wondering what's going on. It's because you did not break it. You have to break it every single time you write a case, you break it. Even for this default, you can still break it. But sometimes it's not necessary because there's nothing on beneath this circle, but it's still a good thing to break it so that you don't have any errors. So let's say our card here is two. Someone gave us two and we are supposed to pick two. Okay. So I'll run this code. You see that what is supposed to show up here is pick two. Okay. So here is pick two. So instead of all those long switch statements that we're writing, if this one, else if this one, we have come here now and we have written something so short that just loops through and checks if this value is equal to this and just does that so easily for us. That's one of the advantages of using switch statements. Okay, so when you know that your if statements are going to be long, they are going to evaluate so many options, so many branches of ways the thing could show up. Don't use if statements, use switch statements in Java. Okay, they will save you a lot of time and all that. So let's again evaluate that person gave us 14 and we are supposed to go to the general market or something like that. Yeah, general market. Okay, so general market, you are going to go to the general market because the person dealt you 14. So that's how switch statements works in Java. I hope you understand that. I tried my best to explain it to the best of my understanding using this game that everybody loves. I think everybody loves this game actually. I don't know who. I've never met anyone who hasn't played this game actually. So that is it for its switch statements in Java. Okay, so let me go to the next one. When statements and expressions. Okay, so there are two ways to use when statements. To use when in Java, you can use that a when statement or a when expression. Okay, so for the first one, um, when okay, this is an example of using a when statement. You have this card here that you have been dealt. This card is 14. You have been dealt 14, so you are supposed to go to the general market. It's still the same thing with switch statement looks the same, it feels the same. Okay, so you have this variable text here, which is a string that's supposed to show you what you're supposed to do. It can be text or display. I just put it as text here. Okay, so when card is equal to 1, the text will be set as hold on. When card is equal to 2, the text will be set as speak to. When it is equal to 14, it will be set as general market, or else it will be set as continue. Okay, and then you print out the line here. So let me show you how this code in my repo. So it's still the same thing here. Okay, so this is it. Let me give some space between that and the other one. Okay, so let me uncomment this code. I don't think I need anything from the previous code. Okay, so this is the code that um, explains when statements. Like I said, I just stopped out the code so that it's easier for me and you to do things. I don't have to type out everything manually, and you don't have to follow me typing out. It's so boring, and I don't actually enjoy doing that anymore. Okay, so not I don't actually enjoy doing it anymore for tutorials, but not for coding. You can't say you can't. I've never met a coder that says um I don't enjoy programming. That's very unrealistic. Or I don't enjoy typing out my code. But, I mean, okay, so this is the same thing with the switch statements. It's almost the same thing you can see, but the difference here is this: there's no case here. You just have this arrow here that points to what you want to run. Okay, so this for this part here, I'm doing this here in one line because it is a statement that can enter a one line. If the statement was longer or the something I had to evaluate was longer, I would have to put a braces here. So you can actually put braces here. Okay, the braces will cover everything, and you can actually carry this part down. This will also run. So when is one, run this block of code. Okay, but for other simple parts of the code, you can just put just everything in one line. If you can put one line, you don't need this braces. Okay, you can just put everything. Okay, another difference or something again you notice about this one is that in the if statements, we have the defaults here. Okay, it's the defaults that is used to break the statements, not break actually, it's actually used to how do I put it in my own words? It's the case that when other cases don't run, it runs. Okay, it's like saying the default statement is the statement that um runs when you can't match any of the other cases. Okay, let's put it like that. The default statement is the statement that works when you can't match any of the other cases. Okay, so but in Kotlin, we don't have that default. We have the else part. Okay, or the else block. Okay, so instead of using that default Kotlin, they actually changed it and used else. So that's the two difference between Kotlin and Java in that respect. So let's run our code. Our code should run general market actually. So since it's 14, we have been dealt 14, um, should say general market, and then everything. Okay, that should be the code. I don't know why Java Kotlin takes so much time to run. I actually prefer using my IDE, but because it's a new language for most people, setting up the IDE may take you uh, a bit of time. So I'm just trying to use this. Okay, so I have an issue actually, and it says last check card is never used. Okay, this is a warning. Variable last check card is never used. Okay, so this is because of this one. Okay, so if I comment this out and run again, it should work, but I'm not going to run again because it takes so much time. Just look at it here. You can say warning variable last check card is never used. Not that, but I should have commented that out if I actually run the code. But you can see here now I have general market showing, which is what I actually supposed to have here. Okay, let me comment this part out now. Um, let me show you about when expressions. It's the same thing as an if expression in a way. Instead of you using when statements like this, you actually use it and use it to assign a value to a variable. Okay, so it's in the right hand side of the equal sign right now. So you can see that the when expression now, the when statement now is not an expression. So it's a when expression. Okay. So it's let me show you the example so that I don't actually bore you with this. Okay, so here's my example here. Okay, so this is my last card again. The last card on the deck. Okay. If card here is equal to 2, you should say pick 2. Okay. But instead of just doing that pick 2 here directly and setting the text, calling this text, setting this text, you can actually say this text is equal to when. Okay. That's the difference. Instead of writing the text when and then calling text is equal to this and changing the value of text, okay, you can see when the is equal to, when this happens, set this value. When is this happens, set this value is equal to this. Okay, so it sets the hold on equal to the value of the text whenever it's 1, or it sets pick 2 to the value of text whenever it's 2, or it sets general market to the value of text whenever it's 14, or continue to the value of text whenever it doesn't match any of the other parts of code. Okay, so let me run this one time. I think I should run all my codes and um show you guys how they work so that there will be no confusion in how it works. So for this one, it should show pick 2 actually. I haven't told you guys that. So because the value is 2 and this is 2, it will set the value of pick 2 to text here. Then you now print out the text. So you should show pick 2 here because you are printing out the text. But if you don't print it out, actually, nothing will show because it just sets value of variable. Okay, so it shows pick 2 and everything runs according to normal. So I'll comment that out and revisit this part so you can see my when statement and my when expression. I hope that was not very confusing for anyone. If it's confusing, again, you can reach out to me and ask me questions. I'll gladly answer your questions actually. So let's go to the next part of the slide. Okay, so things to note: Kotlin does not have switch statements; they have when statements. Okay, so you notice that when I did that part of the code, there were no switch statements; there were when statements. When statements require. Okay, sorry, this is an error. Switch statements actually require breaks, else the code falls through. Not when statements. This is an error here. I'll actually um edit this and uh, fix that. Okay, so remember to add defaults or else branch to your code. Okay, so for people that can't hear me, uh, switch statements. Let me fix this now so that people that can't hear me won't think I made this mistake intentionally or something, or won't assume any other thing. Switch statements require breaks, okay? Else the code falls through. Remember to add defaults or or else branches to your code. Okay, just this is just like uh, a good thing to do in case your code does not have every other thing that you try to match does not work. There should be a default. Okay, default or you add your else in Kotlin. Default in Java, else in Kotlin. I hope that was very self-explanatory. If not, feel free to talk to me. I'll explain everything about it to you. Okay, so we're going to the next part of the explanation. We're going to talk about arrays in Java and arrays in Kotlin. Okay, so an array is a container object that holds a fixed number of values of a single type. So arrays, I like to think of it as a container. That's why my explanation says it's a container. Okay, the length of the array is established when the array is created. After creation, the length is fixed. What does this mean? It means that arrays in both Java and Kotlin are limited. You know, Java and Kotlin are very similar. They target the same platform, that's JVM. Even though the Java language is different from the Kotlin language, they both target the same target. They have the same target. That's the Java virtual machine. Okay. Kotlin also targets some other parts like iOS. You can use Kotlin to target iOS and JS and all those other stuff. You can actually use Java to target some other platforms and other things. But for our code, which is Android, Kotlin, both Kotlin and Java are targeting the JVM. So they both have the same similarities. Okay, but their difference is in the way they work, like the way you declare things here. Okay, so you can see here that arrays in Java are different from arrays in Kotlin the way you do it. Okay, so let me show you the example of arrays in Java. Okay, I stop this code out. So um, arrays are basically like containers that you use to hold things. Okay, let's say I have this container now. I want to put numbers or the cards that I have. Okay, this is my array. I will say my array. Okay, dot add. Sorry, the puts. Then I put one. Sorry, can I think something is wrong here. Okay, so I figured out the error here. Uh, sorry, I put here instead of putting setting the stuff. Okay, so my array. Um, okay, so zero. Um, so I was looking at that for and wondering why it was not working. I was actually using the method to add it actually, but that's not how array works in Java. I yeah. So don't that add or put is actually for lists and collections. Actually, we don't use that in arrays. So and I think I've been using lists so much that it entered into my head, and I was like, "What happened?" And it just took me around 2 seconds or something to realize that I was actually making a mistake there. So let me put this, let me copy this and then duplicate that. Okay. So mm, so so array starts at 0. Okay, and let me make a mistake. Let me make a mistake here. I want to um I want to cause an index out of bounds exception. Okay, if that's what it's called actually. I want to make a very understandable mistake. My array here I created is an array of 4 items. So you can see from my presentation here, I said after the creation of arrays that they have a fixed length that you can't pass that length. Okay, sorry, I went to my Kotlin repo rather than my Java repo. So I've created my array here. It's an array of integers. Okay, and I've given it the value of 4. That means my array contains 4 objects. Array starts with 0, so this is my zeroth object is my first object. I've given my zeroth object the value of 1. I've given my first object the value of 3, second object the value of 4, third object the value of 5. Then I'm calling the fifth object here. So this 4 here is actually the fifth object, and there's no fifth object. And when I run this, you should actually see an error if everything out of bounds for length 4. That's what I was trying to show you guys. When you create an array, when you set the size, okay, the length is fixed. That's what I mean by the length is fixed. You can actually start adding extra things to the length and it will start expanding. That's not how arrays work. Arrays are fixed. Okay, so, but if I remove this part now and I run my code again, my code should work. And if I say something like um, I wanted to avoid typing, but it seems I can't avoid typing. Mm, Um, yeah, sorry. Yeah. Okay, so I can do my array dot length to know the length of my array. We both know my array. The length of my array is 4 actually. So um, it's actually just trying to know my length again. So apart from this length, there are also other methods that you can call on arrays. Not going to go too deep into that, but I'm just going to show you guys how basically arrays work and how they are structured. They are structured in a definite and tight way in the sense that when you create them, you can't actually expand their values. Their values cannot be expanded. That's okay. So that's it. For arrays in Java. Let's talk about arrays in Kotlin. Okay, so arrays in Kotlin. Let me first of all comment that part out in Java. Arrays in Kotlin are not very hard to instantiate. You can actually do that on one line. Okay, so this is just an array in Kotlin. You set the value. You can even set the value when you are creating it directly. Okay, so it's just like array of 1, 2, 3, 4. And that function just returns you an array. Okay, so arrays in Kotlin are not just that hard. Like I said before, Kotlin was created after Java. So they try to eliminate some of Java's verbosity and all those other stuff. So that's why you can see some of the syntax are simple. You don't need to add the semicolon and you don't need to do some ceremonial things that Java does. Okay. So if you also see same thing, if you say print and then you see numbers size. Uh, was it size or length? What's uh, what okay. My intelligence is not helping me out. I haven't okay. Numbers dot. So let me just run that. I'm actually making a mistake there. H. Actually, think size. Okay. Actually, wait for my program to stop, and then can check the array stuff. Okay. So if my program can stop, I'll check it. Okay. So the program actually ran and uh, it didn't work. So let's run it again. It's not supposed to be length. It's supposed to be size. Actually. So size, not length. This always confuses me because Kotlin changes most of the methods that you call in Java, call length, and Kotlin you call size and all that. So Kotlin takes a lot of time to run, but it should return 4, which shows that the array is of the size of 4, like this one that we did here also. So the same size. Mm, okay, so that's still running. This is taking a very, very long amount of time. I don't know why. This is even longer than Android Studio building. What are they using to run this? Is it Gradle or something? Oh, so long. Okay, so I'm still building, and I should stop this, please. Don't waste my time. I don't understand. It takes a lot of time. Stopping is now an issue. Is there ways to stop stopping? Nope. Okay. I think I've done too much. Um, Now it's not going to stop, and now it's not going to run. I don't know what to do. Let me cancel that. Still doesn't help me. Ah, okay. I think I'll just have to refresh this page. Okay. It stopped, and now I can run it again. Okay. So my code is actually taking a very, very long amount of time, and I can't tell why. Just like 2 lines, and that is why I don't like rebels. It's so much. I mean, how many minutes? Okay, so it has run, and it runs for as my size after almost a week of waiting and waiting. So that's it for arrays in Java and Kotlin. They're basically the same thing. So in Java you call length, in Kotlin you call size. I made the mistake of calling length the first time. Then I quickly realized that it was actually size, and then changed it back to size. That was one of my mistakes. But mistakes happen, so everybody should put that in mind. So let's go to the next part of stuff. I hope you guys got this section. Let's go to the next section. Collections. So for me, I like to define collections in layman terms as the bag that holds similar content together. Yeah. So connections are generally bag that hold similar contents together. So for collections, there are three major types. There are lists, there are sets, and there are maps. Okay. Maps are also known as dictionary sorry, in languages like like Python. Maps are known as dictionaries and some other. Um, sorry, excuse me. Okay, so there are lists, there are sets, and there are maps. In languages like Python, maps are also known as dictionaries. List is an order paired. Okay, sorry everyone. I was having a bit of dry throat there. So list is an ordered collection, access to elements by indices. Okay, lists have indices and numbers that reflect the position. That's what this statement is just trying to show. It has things that are ordered, and then they have indices that reflect that position. So list is basically like a bit of its arrayation or something like that. They have a position. Like in arrays, you're seeing zero, you're seeing one, you're seeing two. I was trying to set the values one after the other. Okay, so that's basically what lists are. Then there are sets. Sets are a collection of unique elements. So sets don't have duplications. You can't have a set that contains two, and then come again in that set and add another two. That second two will not be added. For sets, in sets, everything has to be unique. So if you have one, two, three, then you add another two again. It should just be one, two, three. Okay. and maps, they are a key value pair. The keys are unique, and they are and each of them maps to exactly one value. So they are a key value pair, and I'll show you how they work. So, how they work in Kotlin and okay. So for lists, this is another pair. It's just the same thing I said before. I don't know why I'm repeating it, but they have indices integer that reflect their position. So basically, let me go to the chapter report. Um, this is how you represent lists. You say list, my list, then you create a new array list. So basically, in reality, this list here is an interface. Okay. So you have to use this array list here to create an implementation of it or something like that. Then you add whatever you want to the list. So this list now is now a list of numbers or phone numbers or a list of integers. I can't add strings to this list. I can't add any other data type, only integers. Okay. That's when I said um, a list or a collection is the bag that holds similar items. Okay. So you can have this bag now. This bag now, and I say this my list, go to new array list, and I add just that one here. That bag has automatically registered that okay, I am a bag that holds integers. I don't hold any other thing. So by calling adding one, you have implicitly said that this list holds just um, the value integer. Okay, so let me go here and show you an example. So we have list. My list is equal to a list, and I add this and this and this, and okay, I can actually do more good examples and array list and then arrays. I don't know. My intelligence is not working. I don't know why intelligence is not working. There's no suggestion, no nothing. It's just empty. And that was why I was busy typing something else in Java. Okay, so I'm getting an error for this. Why am I getting an error for this? Okay, error is gone. That was crazy. Why am I getting an error for this? So this is my list. I want to know size of my list. Okay, so size. Okay, I can print out this size. So lists are actually they expand based on what you put inside. If they're not like arrays, that's why one of the reasons why collections were created. When you have a list of three and you add extra items, the list expands and it can contain more items. I can add a whole lot of items and the list doesn't care. As far as I keep adding, the size of the list keeps expanding. It doesn't really matter. In arrays, you just have to fix it, you just have a fixed size. And that is why people prefer collections and lists over arrays most of the time. Okay, so if you run this and you see that my size of my list is actually three. Okay, so my list contains three items. I should actually learn to use print line rather than print because print line does it on a new line, but prints actually just print it. Okay, so you can see this three now comes on new line. The other caret is on a different line. You can see my answer here is three based on the size of the list. But if you want to get the list now, okay, so let me say list dot get, and I want to get my first item on the list. I know my first item is one, and my second item is two, and my third item is zero. So to get my first item, I just have to add zero. Okay, so for list and arrays, everything starts at zero. My zeroth item is one. My I know I'm contradicting myself here. I just said my first item is one, and now I'm saying my zeroth item. The computers recognize this stuff from zero to whatever value they have. So in essence, your first value is your zeroth item. Okay. So to get this first item, I'll just put zero. and here, and if I run it, it should print out one. Okay, so it prints out one. Okay, so 0 is the number for the first item, then two, one, then two. This is one. This is 0. Okay, this is sorry, one. This is two. So that's how the stuff goes. Okay, so I hope you understood list in Java. Let me try to explain this in Kotlin. List in Kotlin, as you can see, Kotlin is more easier than list in Java. Um, Let me comment this part out and go to the Kotlin repo. A list in Kotlin and list in Java um, basically almost the same thing. Okay, just a list in um, Kotlin are easier to instantiate and use. You just code this and list off and you add whatever you want to list, and then basically just returns you a list. Okay, so that's like an easy way for you to create a list. But you can also see that if you use print, okay, if you print numbers, okay, so, yeah. If you print number dot size, it will still give you the same size for, but you can still increase the size and add more items and then it expands. So basically, list in Java are still the same thing as list in Kotlin. I will not talk about things like the nullability or how it's null, whether you're using a mutable list or immutable list and all those other things. Those are complex topics based on Kotlin. But for the base understand lists in Java are basically something list in Kotlin. They're actually interoperable and all that. So you can see my size also returns 4. Okay. Um, if you add more items, actually the size will still expand and all that. So I hope that was clear and very straight to the point. I don't want to confuse anyone. Okay, so let's go to the sets. Okay, sets can be defined as a collection of unique elements. I've explained this before. Mm. Okay, so this explanation here is actually very robust. Um, I'm actually going to okay. So this explanation here is robust. It's not actually uh, sorry, the assignment here is very robust. It's not actually very explanatory. It's supposed to be nice. Sorry about that. So I had this angle bracket here that I was actually using before, but I removed it because it's not supposed to be that. And let me show you my screen again in full screen. I know you can see my screen, but let me show you in full screen so you can actually see everything. Um, this is set. Set has a collection of unique elements. Okay, so this is how you create sets in Java. See set, my set is equal to new has set, and then you set whatever you want. There are many implementations of the set interface actually, just like the list interface in Java, but you just consider and just focus on the most popular one, which is the hash set. Okay. So you can now add things, and this is why I was trying to do that add I put in arrays, and I was making a mistake. I just needed to use the angry braces there. Okay, so one of the mistakes. Okay, so let me show you how to use sets in Java. So this is also a boost. It's not supposed to be there. Um, the type is actually inferred. You don't have to add that extra information to show the type. The type is actually inferred when you pass the first parameter. As you pass that first parameter, it actually knows what type it's going to hold. And you can't come here and start adding something else. There should be an error here. I know this is a repo, but it's not going to show the error. It's not going to be as fast as an IDE to detect the error. But if you run something like this, you should have a big error that says you're not supposed to have. Uh, you're not actually supposed to have that. Okay, so it just says these unsafe operations and that. It's not really. I don't know why this record is not really it's not really working the way I want it to. But it's good for our example. Um, uh, you're actually supposed to have a type in your set and your list and your map. Okay, so that's how it works. You just basically have to put one. Once you put the first one, it's in first. And once you add another one that's not of the same type, or you add something that's not maybe a string or a double or whatever, it doesn't actually work. Um, uh, Something that's not the same type. Maybe a double will be boxed or unboxed, but maybe a string will not work or a complex object will not work. That's just what I'm trying to tell you guys. A set will just refer. No need to call that angle bracket that you see there. You can refer the stuff on its own. Okay, so that's it for sets. You can there are so many operations you can do on sets. You can call the size. You can get the elements. You can uh, do mostly basic. Most of the things you actually do with uh, lists with sets. But the thing about sets is that okay. Let me show you this here. I added one here. I added two, and then I added three, and I added three again. So when you call this uh, call, okay, every time I get issues copying things. Why? Oh. Okay, so let me do this and show you guys. I'm not playing. My set. I think it's called the size. Yeah, I'm not getting any lessons and no help at all to know if it's correct or it's not correct, but it should be correct because size method that get is saying it's not correct. It's correct. I don't know why it was writing that line. Okay, let me do sprint line so that it shows on the separate line and nothing blocks it. So you can see that the size there instead of being 4 because I added one, two, three, and then another three is actually three. How? The last three I put was removed. It was not actually added to the set. Okay, sets have to be unique. Everything in it has to be unique. So because three is not unique, there are two threes here. Only one is taken and the other is discarded. So that's how sets. If you need a collection or a bag to put things that are you want them to be one in a million, but nothing else will be like that. Use sets. Okay. I hope that was clear to understand. And I'll be commenting that part out. Or sets in Kotlin. They're basically the same thing. Let me go to my Kotlin example and comment that part out. You create sets using this simple function. It makes sets for you. You don't really have to know what it does or how it works underneath. Just need to know that this is what you just have to call to create your set. Um, let's say again, after you creating your own set, you now come again, you now call for two times, just like you did in the other one. You called three two times. Now you call four two times. So I have one, two, three, four, five items in my set. So normally you should say uh Windows Calling numbers dot size should give you 5, but here when we call numbers dot size, it should give us 4. I was actually going to check if I had commented the other part out, but it's commented out, so my code should run normally. Okay, so it's still running. Kotlin takes a lot more time than Java, so I think we just have to be a little bit patient with me. Um, Maybe next time we will not use the repo. I don't think this repo was a good idea actually, because the picking of the for it and all this stuff is not even worth it. Okay, so maybe next time set up my IDE and I'll run you guys through the process. I don't know if you guys have been shown how to do it before, but it should work. And um, it should be faster than this. It should be painless because I've been waiting. I'm sure there are some Android apps that compare faster than this actually. And I don't know how to do it, and I don't know how it runs in the back, but whatever they're doing is um, just too long. It takes too long to run. And this is just 2 lines of code. I wonder what happens when I have a very long list or a very long line of code. Or is it because I'm in number 231, 232, and I have a long space or something? Okay, so after 1 year and 6 months, my code has returned and it says my value is 4 when I have 5 items. Okay, so I have two fours here, and one of the fours, because it's not unique, has been popped out, and uh, it just returns 4, not 5. So that's just a basic intro into sets. Everything in your set has to be unique, and everything in your list shows has an index. You can get the 0th item, you can get the first item, you can get the second item, or the nth item, whatever the size of the list is. Okay, so for the final part, we have maps, also known as dictionaries. A set of key value pairs. The keys are unique. Each of them maps to exactly one value. So you have this part, map, my map is equal to hash map. Okay, this is how to create map in Java. Okay, so let me run you through. Map is actually an interface, and you have to create or associate it with using the implementation or the hash map implementation. Okay. So basically, it's still the same thing. Okay, so let me show you the repo code for maps here. This is it. So this maps actually have come in two key value pairs. Okay, I explained that before in my presentation here, but when you look at it here now, you can see it, and it's very obvious. You can see map here. Okay, so we have maps. You put the key. The first part of the map or the put is the key. So you notice that in maps, what maps sets and lists have in common is that they have expandable values. They are not like arrays. If you put an array, you have to come and resize it and other things. Maps are not like that. Lists are not like that. Sets are not like that. Okay. They actually can expand no matter whatever you put. Okay, so I have this map. I say put 1, and I put the value of 1. I put 5, and I put 2. Put 2, and I put the value of 3. Put 6, and I put the value of 4. Okay, so I just did that a little bit randomly, not really orderly. You can see, you can understand the way it works. Okay, so that's how maps basically. Okay, so that's it for the introduction and the ways to use the maps in Java. Okay, you can see I just put the key value pairs there, and then if you want to access the map, I just say get the value. Okay, so use put to insert into maps, not actually add. And then when you want to get the value, you just insert the key, and then the value is returned for you. I'll give you examples of how that works very soon. I just have to show you how it looks in Java. So for Kotlin, it's actually easier to do maps in Kotlin, just the same way it's easy to do any other thing in Kotlin. Kotlin was really thought of, and we just wanted to make things very easier for developers and that. So the things with Kotlin are very easy. So you still have this simple function, just pass the key and the value. Key one, you notice in my uh, Java, the keys are integers. How do you, the values are strings. But here the keys are strings and the values are integers. So it doesn't really matter. But in Kotlin, you can just say the key to the value and then add as many as you want. On the key 2 to 2, key 3 to 3, and every other thing is just done and your map is set up. Okay, so let me show you how to put the map up. Okay, remember start. Okay, here is where I'll do. Okay, so okay, so I do not have. Okay, the mistake is here. Okay, numbers map, not numbers. Okay, that's gets and actually pass this. Yes. Okay, so run. Okay, so I'm trying to get the first item on my map, but I passed my key as or what I need to identify the value I want. Okay, it doesn't really matter. Maps are not really arranged in a linear fashion. It doesn't mean that if I put key one here, that key one will come out first, or if I keep it key two first, the key two will come out first. Same thing with set. They're not really orderly. Only list keeps the order. Okay, so I try to find my value based on my key. So I passed my key. My key is key one and is a string. So I have to put these quotations here into the get parameter and then it returns one. Okay, so you can see my value here is one. And same way you do it with Java, you just use your key to find your the pair the value. That's why they call key value pairs. The keys help you find the values. Okay. There are other complex operations that you can do with them, but I'll be taking that in the next class on loops and other stuff. I'll talk about loops and how to use loops in collections too. So advanced for loops and um, using them in maps and all those other things. But that's not for this class. I'm not trying to confuse it for this class. This class is like an introduction to what you'll be doing. Okay, so that's actually the end of my stream and my class. This class would not be live, so I had to record and present to you guys the recording because I'm busy doing other things. Okay, so I hope you guys love this teaching. Um, Hopefully my next class will be live. But thank you all for coming. Um, I had a good time recording this. A good and stressful time actually. This is the like I said, this is the end time I'm recording this actually. So thank you guys for watching and bless you.